Mepa Enerji ve Cummnis'ten Power Ability in Datacentres, DCC, ISO Standards and Redundancy Models başlıklı sunumuyla Fehmi, Emre, Yılmaz ve Muhammed Yusuf geliyor. Alkışlarınızla. Mikrofonlarını takmayı unutmuşuz da kusura bakmayın.
Merhabalar, herkese hoş geldin. Ben de Türkçe devam edeyim.
My name is Mohammed, Yusuf, and I'm from Cummnis Power Systems, and I'm from UK office.
Fehmi Emre Yılmaz, ben de Mepa Enerji sistemlerinden geliyorum. Marmara Bölge Satış Müdürü olarak buradayım.
Perfect. Okay, so today's presentation is going to be on data center ratings as per the ISO, as well as we're going to see what is the Uptime Institute is requiring whenever you're selecting machines for data center applications. Okay, so first thing is first, we're going to see what is the ISO standards definition for data center power. So we're going to have a deep dive into understanding what is the ISO standards demanding for data center applications. Then we're going to see what is the Uptime Institute requiring you to have the specifications when selecting machines for data centers. And we're going to see how does Cummins use that for data center applications and some typical examples for data center installations. Okay, so this is going to be the presentation for the day. First thing is first, the ISO 528 standards. The ISO 528 standards, part 1 or -1 standard is mainly used for both gas or diesel generator sets. The main purpose of the particular standard is to explain to you what you need to take into account when selecting machines for a particular application. Okay, so they have used number of operating hours, load profile, whether it's a constant load profile or a variable load profile, and to define what should be your rating, including standby power, primary rated power, data center power. Okay. First thing is the definition point of view. ISO standards again have defined using the number of hours to be unlimited number of hours. So whenever you're going to have a generator set selected for data center power from ISO point of view, the application is going to be for unlimited number of run hours, and it needs to be the maximum power that you can get out of the generator sets to support all of the loads. Okay? So you need to take into account any radiator fan power, you need to take into account battery charging alternators, or any other parasitic loads like heaters or whatever that is, loads that you have got into account, and then give whatever is the final power. Okay? And most important thing which I have highlighted for you is that in red is the availability of the utility. So as per the ISO point of view, for a data center application, you need to have a reliable utility as the primary source of power. That is the main requirement. Okay? Compared to all the other requirements set out from Uptime Institute point of view, the ISO standard says you need to have the reliable utility, and whatever generator set that you're going to have on the site is a backup generator set. So please kindly understand that. Okay? So we have given that, and because the ISO standards is saying the utility is the reliable source and not the on-power generation sets on site is a reliable source, it will not be able to meet any amount of TS certifications that is required by the uptime. So what does Uptime Institute needed? We're going to see that in the next slide. Okay, so Uptime Institute point of view, if you're going to have a project for Tier 3 or for Tier 4 applications, it's very critical that whatever generator set that is available on the site should be able to meet the complete data center power requirement. So if you're going to have a generator set on the site, let's say for example 2000 kVA, of power, and if the data center load is 2000 powers of kVA, if for any reason the utility is out, then the generator set should be able to deliver that required power for unlimited number of hours, no matter what the load profile is. It could be a continuous load profile or a variable load profile, but it needs to deliver. If you don't, you do not meet the requirements set out in the Tier 3 and the Tier 4 requirements for Uptime Institute. So what did we do in Cummins point of view? We started to develop our own rating. So I think this is back in 2012, 2013 itself, before data centers became the biggest application. From Cummins point of view, we started to develop this rating called as the Data Center Continuous Rating, which is Cummins' own DCC power. And more critically, this particular rating was developed with the Uptime Institute, and all the generator sets that's available from Cummins, which is Data Center Continuous or DCC, is already Uptime Institute certified. So for example, if you have got a Cummins DCC data sheet from our websites or from through our Mepa, that generator set is already compliant with what the Uptime Institute is asking. So the Uptime Institute is asking the on-power generator set that's going to be installed to be fully capable of supporting the complete data center load. Okay? And you can see that the genset is the primary source. That's the major difference between the two of them. You got data center power, and then you got ISO DCC coming in as well, with Uptime Institute DCC as well. Okay, so Cummins and Uptime, that's the major difference. So what we do in Cummins is sometimes for the Uptime Institute certification, you do need a letter or you do need additional documentation to get your particular data center certified for Tier 3 or Tier 4. And in Cummins, we issue the letter for the generator sets that have already got the data center ratings power, and those letters will help you to satisfy the requirements set in Tier 3 or Tier 4 requirements. Okay? So, but please note, this particular letter that we are issuing from Cummins is very specific for that particular data center. So if you are going to have a project in the early stages where you do not know, all the details and particulars, and you wanted to start with the project specifications, you can always use the published Cummins DCC data sheets. You do have them in our library. You can go download and you can use them for the initial stages. Once your projects get to a stage where you needed additional documentations, speak with us and we are happy to provide you this letter where you can use it for getting the required certifications. Okay? So quick recap of what I've been talking about, differences between the data center continuous versus the data center power. So data center power is from the ISO 828 standards, part 1, which clearly states that you need to have a reliable utility power supply, and whatever generator sets that you're going to use is a backup secondary source. It's not the primary source. Whereas the Uptime Institute for Tier 3 and Tier 4 specifically data centers, say for example for critical strategic data center customers, you will be looking into Tier 3 and Tier 4. Your generator sets that's installed on the site is the primary source, and it cannot have any kind of a downtime because of a utility failure. The utility becomes the backup. That is the main difference. Okay? So the Cummins DCC rating does not call for the presence of the utility, and we can therefore meet all the requirements set out in the Tier 3 and the Tier 4. So to understand this Tier 3 and the Tier 4, we thought it would be best to put you into perspective what do you mean by number of generator sets on site. Okay, pretty much most of you will be thinking, okay, if I say number of genset is 1 or n is equal to 1 genset for the particular project. Please understand, Uptime is very clear. Whatever number of generator sets that is needed to meet the full site load is considered as n. Okay, so if you're going to have let's say 4 generators or 3 generators to meet the complete data center load of the on-site, then that is the number of gensets. So n is equal to 3 there. Okay, 3 gensets form one single group. Okay, so that's exactly what I've shown here. So 3 generator sets or needed to meet the complete site load requirements. If that is going to be the case, N here is going to be all the 3 gensets put together. Okay? So this could be for a tier 1 or a tier 2 data center for as per the uptime point of view. Okay? Now you're going to go for a tier 3 or a tier 4 where you need to have redundancies and concurrently maintainable or fault tolerant topologies. N plus 1. So I'm going to have 3 of the generator sets in the same group and an additional backup generator set so that if for any reasons I've got failure of a generator set or for service, maintenance, whatever reasons, I have another backup generator set to support the complete site load. That is the criticality as per the uptime. You need to always have the number of gensets to meet your requirements. Okay? Then comes 2N. So this is more popular whenever you go towards the tier 3 and the tier 4. So this is very, very popular. So where you want to have 2 of everything. So you got the 3 gensets to form one of the ends and then alternative for the other one. Very popular tier 3 data centers. So you can imagine what will be for the 2N plus 1. So this is more popular for tier 4 data center topology. You need to look into something like this for your tier 4 data centers. And then comes in the 2N plus 1, tier 4 straight away. So no matter what the situation, your generator sets on the site should be able to support the site loads. You cannot have a failure due to any reasons of a genset or due to any reasons of additional parts of supply to your data center load. It's very critical. To help you to understand the topologies, I put in a small slide on the tier 3 and the tier 4. On the tier 3 data centers, you can see N is going to be there and then the N plus 1 arrangement comes in. Okay? You can see this is becoming the utility for supply. So once the utility is a backup, okay? Always the utility is a backup. And the generator set is the main source of our supply. And you can see it goes all the way to the loads. 2 parts are there, okay? Even UPS is considered as an on-site generator. That's why it's also having N plus 1. You also have additional one there, okay? And then all of them coming into support your complete heating as well as your IT loads, okay? So this is for a tier 3 data center. Now I'm going to show you for the tier 4. Everything the same, but please look, simultaneously having 2 parts, okay? And this one is called as a fault tolerant. That means if for any reason one of the parts is affected, you should have same number of available generator sets simultaneously to support all the other loads. So you can see everything is going to be twice, okay? So after a failure, you still need to have an N plus 1 arrangement to support your complete site loads. So this becomes like a requirement for you. So whenever you write it, just be careful to check if it's requiring Uptime Institute certification tier 3 or tier 4 to have a project, single line diagram to be done in a way so that you're going to have always 2 simultaneous parts to support your IT loads as well as the heating and ventilation loads. Okay. Now I've got some typical examples for data center applications, installations, and you can see that this is for a project where we have installed 30 of our generator sets, and pretty much you'll be thinking that this is going to be the data center building. No, this is just a building for doing the pipe works that is needed for the heating and for the HT circuit and the LT circuit. You can see that the radiators are all going to be on this side and the genset is all installed on the left hand side. And that is on the top is the actual data center building. You know, very unique installations. This is a project that we executed for one of the critical data center customer. And you can see what is unique about this one is all the gensets are containerized and each container has got 2 gensets installed inside them. Most of you would have come across installations where only 1 genset is inside per container, but this is a very unique arrangement. That's why I thought it would be good for you to see, where we got 2 of our generator sets installed inside a single container, and you can also see all the pipe work done. The exhaust is going up there. An airflow fan to get the airflow out as well. And you can see all the cabling, everything is done. You can see circuit breaker box coming in, cabling gangways coming in as well. Pretty much everything you need to consider. It also has got a neutral earth resistors, and because it's a HV machine, something for you to take into account whenever you're going to do applications with HV. And then much more deeper pictures, you can see that the airflow is coming up with the rain cap. You can see the air inlet, and then the airflow out is coming up there. And you can see that the complete building was just for pipeworks, for not only just used for the genset, but also used for cooling down the IT, the server loads as well. So it was like a dedicated building housing all the requirements that's needed for heating and cooling. And another installation where we have done, you can see that the air outlet as well as the air inlet, very unique requirement. Can you guess why we have got like this? Because we wanted to make sure that whatever the air that's going to come out in the exhaust or whatever that's going to be there, if the wind direction is going to come in to make it to push it through, we did the CFD analysis, and then we realized it's to come up with a solution in such a way it's not going to be sucking in the air directly into the genset to cause more thermal issues. So we do that as well. We study the site, we make sure the site is having the right way to do the installation, and then we go forward with it. And that is the last one. I open up the floor for any questions you have got.
Thank you for your presentation. Sanırım soru cevap alamayacağız. Dışarıda standımız bulunuyor. Oraya da gelip yine sorularınızı yöneltebilirsiniz. Aynı zamanda saat 4'te yuvarlak masa toplantısı olacak. Yine Mohammed'le beraber oradayız. Sorularınızı almaktan memnuniyet duyarız. Teşekkür ederiz dinlediğiniz için.
No questions? Anyways, I will be in the power generation booth, the Cummnis booth, all day. So if you have got any questions that you want to discuss, just feel free to come around, have a chat with us, and we can help you. Thank you.